Hey everyone, we've currently got 4 days left until World Time Attack Challenge 2019. So I thought I'd show you what has changed on Project 7 Dera since last year. So starting with the engine bay. It's kind of hard to see, but the biggest change we've had is the new Raceonly built bridgeported engine. So previous years we had stock ports running in there. What we've done at the moment is it's obviously a Bridgeport with E&J seals. Fun story is this is actually the second engine that we've had this year. The first one was built by Raceonly back in February. And the day before big time attack with about, less than maybe 2 hours on it, we killed it on the dyno on low oil pressure because I hadn't set up engine protection yet in the whole thing. So it got rebuilt pretty much straight away by Raceonly. Luckily, not too much damage in there apart from the oil pump and some bit of bearing material, but other than that, the engine was fine. The other big change is the new BorgWarner EFR9180 1.05 AR turbo. So this is replacing the old HKS TO4S 0.82 unit. It's obviously a significantly larger turbo and yet spools a lot quicker. One of the things I really like about the BorgWarner is the very linear response it's got. Rather than just sort of banging on the boost, it's building up about 9 psi at the idle of 2000 RPM, and its full boost, which is 22 psi at about 4500 RPM. And it's a major power boost. So last year, I think we picked on the dyno at about 299 kilowatts, just 1 kilowatt short. But we didn't actually do World Time Attack on that because we did World Time Attack with a failed ignition coil, which we only found way later. As well as, boost leaks, exhaust leaks, every possible leak you possibly had. So I wouldn't be surprised based on our top speed if we were doing anything more than, maybe 240 kilowatts. At the moment, this engine has been dynoed at 400 kilowatts. So, 160 kilowatts more, potentially. And a broader, really nice flat power band up to about 8,500 RPM. Now we don't run that in all gears, we've still got the stock gearbox. So what we're probably looking at is running that only in fourth and fifth gears, maybe 340 kilowatts in third gear, and just base spring pressure in 1 and 2. There's no point running more on the 88Rs. Now the second major thing that's really apparent in the engine bay is this duct. So the concept of this duct is to really make use of the fact that we're now running a front mount. For those that have been following this for a while, you will know that this actually car, when I bought it from Japan, came with an RMMER V-mount. And that V-mount was unfortunately banned last year in World Time Attack, so you had to leave the radiator in the stock position. And the moment I saw that, the first thing I thought of was this is really, really good for a sealed ducting system. Now that means that any air that enters the front of the car is forced out of these two vents here. What that does is it creates more downforce through, I guess, two main methods. One is that all the air that basically starts up down here is forced up and over the car. That creates a downforce basically. The second thing is it stops the air from getting under the car, which disrupts the the low pressure air that you've got going under the car. The other thing that theoretically should be able to do is a proper, well-made ducting system should actually decrease pressure behind the radiator due to more laminar flow, which will mean that more air will go through. Now, given that we've kind of got all this stuff in the way, and it doesn't really quite, ideally you just have a big square that perfectly matches this, it kind of hits here and then goes around. That may or may not happen, but it's definitely creating more downforce. We've tested this. The way we tested it is obviously we don't have force transducers or anything like that, so we test balance between front and rear. So without that running, what is the rear wing angle of attack? Chuck it in, see how the car gets unbalanced. It will become more oversteering because you've got now more front bias. And then we increase the rear until we get that. And so we'd be estimating based on just rough CFD numbers on similar wings, because the wing we've got doesn't have the CFD numbers. We're looking at maybe, at 200 k's an hour, maybe 40, 50 kilos downforce, which is not negligible. The other thing we've got here is cooling for this whole hot side. So I mean, obviously we've got the Inconel shield. Now this makes a huge difference. So to give you an example, you know, with the old setup, you always get glowing red hot turbos, even after cool down laps and all that. Would come in, it's bright red. That was causing all kinds of heat around here. I was worried this thing was going to melt. I was worried everything in here is going to melt. So we start off by putting the aluminium piece in here. Obviously aluminium has a really high thermal conductivity, so it's not actually that great as a heat shield, but at least it kind of kept the hot air in one spot. We put in a GCG turbo bag, one of those fiberglass ones. It didn't last. It came out after one track day, just one session on one track day. We pulled it out and it was, you know, we pulled into the pits and it was smoking. We thought there was an engine fire, and when we finally took it off, it just kind of crumbled into pieces. So we decided to go for the, I guess, the top end stuff, which is Inconel, as sold by TurboSource, and this stuff works amazingly. With the turbo glowing red hot, which would probably be, you know, 700, 800 degrees, you can actually touch that. I mean, it's obviously not that hot now, but it does a really, really good job. So we've got that on the turbo, we've got that down here, and we've still got this around here just to keep the heat that's coming off sort of the bottom part in. We've also got this little duct here, so just a little bit of the air actually gets through to there and then flows down and over, takes that heat under the car. The other thing we had was we actually had a wastegate diaphragm failure. So after, I guess, a dyno session, a couple of dyno sessions, and you know, a couple of track days, suddenly saw the boost start just peaking, going to over boost cut. We found out when pulling it down, it was actually due to the diaphragms having gotten way too hot and finally failing. So what we've got now is, you know, I guess wastegate cooling. So I've actually run some water cooling lines that come off the rear housing, down through the first wastegate, through the second, and through the front. So the TurboSmart Gen 5s actually have that port that lets you chuck water through it. Hopefully that solves the issue. I feel like the issue was also potentially caused because it did run extra hot when we dynoed it with the failed ignition. It was glowing more red than usual. So hopefully this means we can set and forget, never will have to worry about that again. Now obviously the other issue that we had at World Time Attack last year, this is potentially the biggest year apart from intercooler hoses popping off and all that kind of stuff, was overheating. So as everyone who has a rotary copy knows, it's very hard to get a front mount intercooler to work. That's why everyone goes V-mount. So we installed the front mount, and within a lap we would hit 112 degrees C, which is very, very, very hot. So one of the things we decided to do was make use of the fact that, as you can see from the splitter, the car actually rides quite high off the ground. The splitter makes use of the club sprint regulations and runs extremely low. What that means is we can actually put a second inlet down here. And we've got this duct, a Frankenstein creation made within like half an hour the night before Big Time Attack, which obviously we didn't end up doing because we killed the car. But it's kind of got a little bit of fiberglass, a little bit of steel, and a little bit of aluminium. But the way this works is this top part here goes behind the front mount. So the air that enters the front mount is forced up into the top half of the radiator. Then what we have is this bypass section. So the air that enters in here through the front there is sort of sent to the bottom half of the radiator. The way this has been designed is to expand with about a 40% expansion rate. Now, obviously we haven't done CFD design or any real testing, but we're hoping that it stays attached down the sides and flows quite efficiently. But what we found once we install this in, overheating issues gone. To the point where we were trying to get some oil data at different temperatures, and we couldn't get it to go above 88 degrees. We wanted to take it to about 110. This thing now cools really, 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 really well. And we haven't seen that much of an increase in intake temperatures, maybe 4 or 5 degrees. It's been hard because you haven't actually tested back to back yet. But it's reasonable. So this has now become a really reliable car, and hopefully that means that, unlike last year, we can do multiple consecutive hot laps and just get a lot of lap time in the car. The other thing is, once we kill the engine, obviously that meant throwing away the old oil coolers. Because the oil coolers were obviously filled with metal, we took the opportunity to upgrade if you look down there, into set rab 330mm units. So we've got now 2 set rabs on either side, aeroflow thermostat and Raceworks AN-10 lines in between. And again, this works really, really well from cooling. The other major change we've had, obviously now we've got a bit more front downforce, so let's have some more rear downforce. So this is the same wing we ran last year, which is an Esprit 052S. We also bought the gurney flap for it. So a gurney flap obviously increases downforce and drag quite a bit. It makes basically has the same effect as this extending the chord length of the wing. Now, when we installed this at Phillip Island when we were testing it a month ago, it created so much downforce and drag that it caused the entire wing, boot to buckle. So it kind of, as it pushed down at the back, it lifted. And that caused the boot to have a big bend, and that was a bit terrifying. So what we've done now is gone for a chassis mount setup. So these are actually mounted to the chassis and then underneath. And so we originally made that out of plywood, sent it off to a machine shop, got that laser cut, and now anodized, and it works really well. So that's pretty solid now. Like, it's not gonna move. Now the other thing we took the opportunity to do while we had that out, this is what the old wing looks like. It sat about there. So it was sitting further back, so any downforce led to a lifting force on the front, and it was also a bit lower. Now under club sprint regulations, the wing can't be higher than the car. So it's actually quite a bit lower than that. So we've actually taken it up so that the edge of the gurney flap is at the edge, at the height of the car, to make use of that. Obviously, we've also had new end plates as well. So AJ made the carbon sheets, just wet lay in between 2 pieces of glass, about 8 layers. The bigger end plate just means that it seals more of the low pressure air from getting to the top, and acts like extending the length of the wing. As for the shape, it looks cool. If you come around here, car square mirrors. I'll be honest, that was more of a looks thing. They are a lot smaller than the old ones, compare. Smaller means a lot less drag. The sharp edges on the end also mean that you get less drag as well. It creates a sort of stable recirculation area, which means that the air flowing around it is a lot smoother. So probably make a little bit of a difference, but yeah, anything for looks. You probably saw it before, but the canards are a really obvious addition. So these are Rise Type 8 brand from Japan. They are fiberglass with a layer of carbon on the top. They're sort of a universal fit. The original ones are a lot bigger and were sort of cut to the shape of the car, which ended up being quite time consuming. They're sort of just mounted on using L brackets down the side, and we've sort of put metal plates behind, sort of long metal plates that stick up, try to stop them from tilting. Obviously it flexes a little bit. Let's just hope it doesn't tear the bumper off. Apart from that, fuel systems obviously have to be upgraded to take the extra power. So I've put in a second Pierberg, the 360 litre per hour fuel pumps to join the one that's already there off the surge tank. And then obviously we've got a Walbro GSS 342 that's in the tank, just acting as a lift pump to the surge tank. In the engine bay, what we've done is we've put in we moved the 1700 injected dynamics injectors down to the primaries. We're obviously idling quite higher, so we can do that, and put in some Bosch Motorsports 2200cc injectors. Take for more fuel flow, and bumped up the base fuel pressure to 55 psi as well. Obviously, some of the other stuff we've done is really related around the RaceCapture track that we've got. So, and obviously, we had this last year as well. That's the RaceCapture track Mark II up there. It essentially talks to the ECU via CAN bus, and streams data via Wi-Fi or Bluetooth to any number of Android devices in the area. And usually, I obviously have the tablet here, which you've got down here. And I usually mount up a phone up here that does the lap timer, which isn't there at the moment. So that's what I had last year. Now the nice thing about RaceCapture is they keep throwing a lot of updates with new features on it. So one of the things that I got was the Shift X2. So this is basically a can controlled shift light. What's kind of cool about it is it's entirely programmable and customizable, and you basically script it by lure and it's controlled by a CAN bus of the RaceCapture. So I've basically got it set up as a shift light, but I have warning lights and all kinds of cool stuff. The other really cool thing about the RaceCapture is the live streaming. So via 3G you get live streaming to the pits. This is the new Podium app, currently in beta. I'm actually part of the beta test group for it, and this is something new that we'll have for World Time Attack. Basically the RaceCapture will be sort of streaming live data through to here. What I've actually got up on the screen here is some of the live data we streamed at Phillip Island. So we've sort of got all our hold ups up here, and yeah, it's a way to sort of provide some live for the pit crew, I guess, to see what's sort of going on in the car, as well as provide a quick method to basically do some driver analysis and setup analysis and all kinds of stuff. The live streaming of data, the live telemetry isn't actually new, but I guess the old app was through a web browser and wasn't nearly as powerful as this one. So yeah, more to come once we actually try this out at World Time Attack, I think. So if you want to check out this car, 4 days time, World Time Attack Challenge 2019 up at Sydney Motorsport Park, it's going to be awesome. The car itself, I think, is capable of a 140 lap, 4.5 seconds faster than what we did last year. I guess the next question is whether I, as a driver, am actually capable of that. Haven't had a lot of lap time this year, but I'll try my best. Obviously, huge thanks to our sponsors, H2Off, Raceonly especially. They obviously built the engine, but Omar has gone above and beyond with this car. He flew down for Phillip Island track day 2 weeks ago just to support the car. He will be there at World Time Attack, giving us some trackside support, and has generally been, awesome at answering my issues, giving me tips and ideas, sorting out the whole Raceworks of parts and spare parts and all that kind of stuff. They've helped us out so much this year. So big thanks to Raceonly, especially Omar, for doing that kind of stuff. And of course Raceline, who will be doing the corner weighting tomorrow and do all the wheel alignments and all that on the car. Ray is the only one I would trust with that kind of stuff. So, yeah, see us there, and let's hope for a podium finish maybe, or a 140 lap, if I can get that one perfect lap. So, yeah, see you there.